Okay, we'll go up and down the rows. So Amber, sine of 30 degrees.
1/2.
1/2. Remember that sine is opposite over hypotenuse. Julia, cosine of 30 degrees?
Root 3 over 2.
Root 3 over 2. Okay, remember that cosine is adjacent over hypotenuse. Thanks. Brett, tangent of 30 degrees?
Root 3 over 3.
Root 3 over 3.
Oh,
Good. Remember that tangent is opposite over adjacent. So it's 1 over root 3, which rationalizes to root 3 over 3. And Nikki S, cosecant of 30 degrees?
2.
2. Agreed. 2 ways to do this. You can know that cosecant is the reciprocal of sine, which means that you flip the fraction. Or you can look at the triangle, 30 degrees. Cosecant, you need to know that it's hypotenuse over opposite. Okay. Good. Chowan, secant of 30 degrees? Good. 2 root 3 over 3. Just like with cosecant, you can know that secant is the reciprocal of cosine, so it will be 2 over root 3, and that rationalizes to 2 root 3 over 3. Or you can know that secant is hypotenuse over adjacent. Nice. Val, cotangent of 30 degrees? Say again? Root 3, agreed. So you can know that cotangent is the reciprocal of tangent, or you can know that cotangent is the ratio of the adjacent side to the opposite side. Thanks. Thank you so much. Excellent. Dominique, sine of 45 degrees? Root 2 over 2. Thanks. Sine, opposite over hypotenuse. Next, Terry, cosine of 45 degrees? Over 2. Cosine is sine's cofunction, which means that the cosine of an angle is going to be equal to the sine of that angle's complement. Well, 45 degrees is its own complement. That's why sine and cosine of 45 are the same. And Nick, tangent of 45 degrees. 1. Yep. It's because the sides are equal length, opposite and adjacent in the 45, 45, 90. Jessica, cosecant of 45 degrees. Root 2. Agreed. You can either flip the sine fraction, or you can know that it's hypotenuse over opposite. And Gabe, secant of 45 degrees.
Root 2.
Also root 2. Secant and cosecant are co-functions, meaning that the secant of an angle is equal to the cosecant of the angle's complement. Hopefully you're understanding these things as we go. Nakia, cotangent of 45 degrees, please. It's just going to be 1. 2 reasons. It's the reciprocal of tangent. So 1 over 1 is still 1. Also, cotangent is adjacent over opposite. So 45 degrees, adjacent side is 1. Opposite side is 1. Okay, so tan and cotan of 45 degrees are both going to be 1. Oh, that would be an issue. Okay, now you know that that was an error. That's okay. Life goes on. Next, Sue, sine of 60 degrees, please. Root 3 over 2. Please notice that the sine of 60 degrees is the same thing as, you tell me.
Cosine of 30.
Nice. Cosine of 30. Because 60 and 30 are?
Complementary.
Yes! Complementary. Very good. Learning has occurred, despite my best efforts. Nikki Brown, cosine of 60 degrees. 1/2. Okay. So notice cosine of 60 is the same as sine of 30. Celine, tangent of 60 degrees. Root 3. Okay, notice that it is the same thing as the cotangent of 30. At a point in the near future, I will have you fill out a chart like this, and I will expect you to do it very rapidly. Okay, and that comes from being able to notice the patterns. Next, Ali, cosecant of 60 degrees? 2 root 3 over 3. Yep, it's the same thing as secant of 30. Back to you, Amber. Secant of 60.
2.
2. Yep, same thing as the cosecant of 30. And Julia, last one. Cotan of 60. It is not. So tell me, what is cotangent's cofunction? Well, that's its definition. You can use that. But to make it quicker, Julia, if you know the tangent of 30 degrees, then you automatically know the cotangent of 60 degrees. Because 30 and 60 are complementary. Okay, so it's just root 3 over 3. Yeah! Any questions on that table? Yes, Gabe?
Just a question in general. If you get a random angle that's not part of those special triangles, is there a certain way you can do that too?
Excellent question. You have options. You could go old school, take out a ruler, take out a protractor. Not very precise, though. Other options. You could look it up like in a book or online. Like there's tables.
But there's no actual
Calculator.
result.
There is, this is a level of math that's much higher than we're at right now. Okay, but when you get to calculus, or if you get to calculus, you will study infinite series. These are summations that go on forever. And fortunately, due to people like Isaac Newton, arguably one of the greatest mathematicians of all time, / scientists of all time, there is now a formula to determine the sine, cosine, tangent, anything for any given angle. But it involves an infinite series. So it's like there's an infinite number of terms in the series. And the more terms that you use, the more precise your answer is. This is how calculators and computers are able to get us things like the sine of 43 degrees by using that.
Use that random number.
Okay. Any other questions? Would you look at that? Would you look at that car? Okay. We're just making comparisons here. So you do have to think abstractly, but I think you can do it. So,